Hi everyone, welcome. And what you're looking at right now is CRYPTEX, an advanced password generator and security analyzer that I built from scratch. This project is my completion of Idea.3 from the AICTE OASIS Infobyte Python Developer Internship, the most advanced task in the program, I believe. So everything you are about to see in this full deliverable for that, um, in this video, the full name is CRYPTEX version 1.0 and it runs on Python Flask backend and a pure vanilla JavaScript frontend. No frameworks, no UI libraries, just raw code doing real work. You can see 5 core modules here listed at the bottom of the slide. Password generator, GAN forge, analyzer, batch export, and hash view. So, hi again, my name is Annika, and over this video, I'm going to walk you through everything, the task I was given, the concepts behind it, and the code, and then a full live demo of everything in as a single feature. So, what the actual task for the internship Idea.3 was, let me break it down into 5 parts. Task 1 was to build a cryptographically secure password generator, not just random characters, but one that uses Python's secret module, respects character minimums, and lets you exclude specific characters or ambiguous ones. Task 2 um, was a strength analyzer, something that calculates entropy, detects patterns like keyboard walks and repeated characters, and gives a score from 0 to 100 and estimates how long it would take to crack the password offline. Then this task 3 uh, was the GAN adversarial simulation, which was my own creativity, a generator and discriminator loop inspired by the machine learning GANs, where the generator starts weak and evolves each round until the discriminator accepts it. Then the fourth task was a paraphrase engine, word-based passwords that are both strong and memorable. Think of it as correct horse battery staple style of phrases, maybe. And the final one was the hash viewer combined with a batch generator that exports to CSV, as you will see right now. So the tech stack you see on the left are the Python 3, Flask secrets, um, Hashlib, Vanilla JS and HTML5 and CSS3. That is everything that went into the project, and there were no shortcuts used at all. Before we look at the code or the live demo, let's look uh, into some of the vocabulary that is important to understand, because every single number, label, and color on the CRYPTEX screen is referencing one of these concepts. So, starting with entropy, this is the most important one. It's a measure of unpredictability in bits. The formula is the length being multiplied by log base of 2 of the charset size. The higher the entropy, the harder it is to brute force. So when you see CRYPTEX display something like 95.3 bits, that number is your entropy. Next comes the secrets module. This is Python's built-in cryptographically secure pseudo-random number generator, or it's generally called CSPRNG. It pulls from OS level randomness, the same source used for cryptographic keys. This is what makes the generation actually secure, unlike the regular random module. Next comes the brute force, the attack where someone tries every possible combination. So CRYPTEX estimates crack time as charset to the power of length divided by 2, divided by 1 billion hashes per second. That's a realistic offline attack speed. Then the charset, that how many unique characters are in play. Lowercase 26, uppercase 26, digit 10, symbols 32, maximum possibility is 94. Every extra character type you add exponentially increases the entropy. Then is the GAN. So this was my added new thing. So this is the generative adversarial network, as you might have seen in the machine learning logics. In CRYPTEX, this is simulated. The generator creates a password and the discriminator scores it. If the score is below the target, the discriminator rejects it and the generator is forced to evolve, increasing the length, adding uppercase and symbols until it finally gets accepted. This is the core idea behind basically the adversarial training. Next is the hashing. So MD5, SHA1, SHA256, SHA512, these are one-way cryptographic functions. You put a password in, you get a fixed length hex string out. You can never reverse it though. So SHA256 and SHA512 are the current standards. MD5 and SHA1 are shown in CRYPTEX for just educational comparison only. They are broken and should never be used though to store passwords. Then comes the pattern attacks. Attackers don't just brute force here, they use dictionaries and rules targeting patterns. Keyboard works like QWERTY or ASDF. Sequential digits like 1, 2, 3 repeated characters like AAA and stuff like those are common. CRYPTEX detects and penalizes all of these ambiguous combinations in its scoring. Then comes the paraphrase. Instead of a complete random string, you chain random words. High entropy, human memorable. NIST actually recommends paraphrases over short complex passwords now, if you can check. Next comes the ambiguous characters. So I, L, the smaller L, 1, and the bigger L, and the smaller O, big O, and 0. They look same in most fonts. CRYPTEX lets you exclude them so passwords are readable without losing security. And finally, we have the CORS and Flask API. Python backend exposes endpoints like API generate, API analyze, API GAN. The front end JavaScript calls these over HTTP with JSON. CORS is enabled so the HTML file can talk to the Python server even when opened in a local file. Alright, so now you know what every element on screen means. So now let's actually go to the code. Okay, so here on the top we have our imports, secrets right here. This was what I was talking about. That's the C Spring, math for the entropy formula, hashlib for SHA, and MD5 RE for patterns. Detection regex, Flask for the web servers, you can see here. And just below that, we have the charset dictionary right here. This is where every character pools live. Notice extended symbols has backtick, quote, backlash, and there are ambiguous string that's what gets filtered out when the user ticks exclude ambiguous characters, as you'll see soon. These are some of the common password keywords. And so here's the definition, the generate password. This is the heart of generator. So look at the parameter list, length, and the length, right? These use uppercase, use lower, use digits, use symbols, exclude ambiguous, minimum upper, all these things. And the logic works in two passes. First, it builds a required list. It picks exactly min uppercases characters, min lowercase, and so on using secrets.choice. Okay, here you can see. This guarantees that the minimum counts are always met. Then it fills the remaining length with random characters from the full char set. Finally, it shuffles using random.shuffle. So this is the random.shuffle. And that shuffle is the only place regular random is used, and it only affects order, not which characters were chosen. The entropy is unchanged. This is clean, correct, and production grade. Next comes the analyze password function. So this is the analyzer and it runs 10 different checks and returns a structured result object. So you can see the patterns here. First, it detects which character types are present in lowercase, uppercase, digits, symbols, and compute the charset size. Then entropy, length multiplied by log base 2 of charset size. You can see the formula right here on the line. Uh, so here you can see the formula. Entropy calculation. Then the scoring up to 40 points for length, 30 for charset diversity, 20 for entropy, then penalties, common password minus 40. And the keyboard walk is minus 12. And the crack time combinations are divided, for the crack time, the combinations are divided by 2 and then by a billion again, and that billion is the assumed offline attack rate. The function returns issues, strengths, suggestions, scar distribution, and pattern analysis flags, all of which the front end renders live. Then we have the GAN simulate. This one. So the GAN simulation, it starts with the weak config length 6, no uppercase, no symbols. Each round, the generator creates a password and the analyzer scores it. If the score is below the target, the discriminator says rejected, and the generator evolves, increases length by 2, then the uppercase, and then adds the symbol. So you can just look at this real time for a good password that's being forming right in front of your eyes and how it's being detected and it's deemed as accepted by the cryptogenic code. And when the score finally hits the target, as I said, the discriminator says accepted and the loop breaks. So you are an eyewitness to all that processes as well. The function returns the full history, every round's password, score, strategy, verdict, confidence. So the front end can animate it round by round, you'll see right now. And then there are some other functions. We just saw the generate passphrase, uh, which was here, this one. So it picks random words, as you can see from the list, from a built-in list. This one is capitalizes them, adds a 4-digit number, and joins with a separator. Then we have generate hashes. So this one, um, it runs the password through MD5, SHA1, and SHA256, and SHA512 all at once using hashlib. And then we have this batch generator which calls the generate password in a loop, analyzes each one and returns the list of sorted uh, passwords by score descending. So the strongest password is always first to appear. Finally, we have the API routes here, and there are 6 of these endpoints, as you can see here. So this generate right here, yeah, this one. So the generate returns a password plus analysis and plus the hashes. Then the analyze one takes any password string and returns a full analysis. The passphrase and the GAN and the batch, all of these, each of these maps directly to the functions we just walked through. So the main block at the bottom here, this one, starts the Flask on port 5000 with CORS enabled. The front end auto detects whether it's being served by Flask or open directly and adjusts the API based URL accordingly. Okay, and then we have the HTML here. So index.html is the entire front end, 81 kilobytes of HTML, CSS, and JavaScript in one file. CSS uses a dark cyberpunk aesthetics, deep near black background, cyan and green accents, as you will see right now. JavaScript state object at the top tracks the current password, the GAN results. and the batch data. Now we can actually go to the live demo. So it's the generator tab here. This is the default one and it's already active. You can see the password length slider here on the left panel, and it's already set to 16. I'd probably take it to 20 now. And below that, there are the character set toggles, uppercase, lowercase, digit symbols, all on by default, um, except the extended and the ambiguous. There are also these two with the backticks and slashes, and the no ambiguous toggle, which removes I, L, and the similar looking ones. Then we have the minimum counts over here. I can force at least two uppercase, two digits, two symbols, and this is important in enterprise environments that mandate composition rules. And I think I can just generate one password. So the password appears with the matrix scramble animation. As you saw, you can see the strength meter with the fortress here. It shows the level, the score, entropy in bits, and estimated crack time. Here's the crack time. You can see all of these. On the right, you can see the character distribution chart, issues if any, the strengths detected. Below that, the hash panel showing the MD5, the SHA1, SHA256, and SHA512. And you can just click on any of these to copy it to your clipboard. The copy button grabs the password to your clipboard with a flash animation, as you saw, and send to tryout pushes. So this one is the tryout. We'll come back to it. Okay. Then we go to the passphrase tab right here. We have this. Again, we have another word count limit here. I can set word count, separator, toggle, capitalization, again, everything right here. So I have this already set on 4, and the separator is dash. That gives me something like quantum slash nexus slash stellar slash falcon slash, so something like that. Notice the analyzer treats the whole thing as a password uh, when it calculates the entropy. So let me just get this one. So yeah, it's calculating everything as a password and calculates the entropy based on the whole of this phrase. Now I'll just exclude something. I'll show you how this works. Although you have this one here, I'll write field J, or I'll just put one, and now every password from thus far will have none of these characters inside it. Okay, so this is what this particular functionality can do. Okay, next we go to the GAN forge. Now the GAN forge, this is the most conceptually interesting module. The set round is right now 8 and the target score is 75, and now I'm hitting the forge. Watch the two columns. Left is the generator, and you can see each round's password. The strategy is it used length, whether it is using uppercase, whether it used symbols. Right is the discriminator. It evaluates each password and either accepts, so these were the accepted ones, or it rejects. So each one above were the rejected ones. Round 1 is always weak, short, lowercase only. The discriminator immediately rejects it. Generator adds uppercase, rejected, adds symbols, gets longer. Eventually, the score crosses the 75 threshold and the discriminator accepts it. The footer shows the final password. This is the final password. And the final score, how many rounds it took and whether it converged, meaning it successfully found a strong password within the round limit. Now click use this password, and again this will by default go to your tryout area. This sends it to tryout. Now let's actually go to the tryout tab. You can just inject this from the generator, either of the two generators. So I'm just injecting it. It's already done. There's one default, so this is just a simulation, so it's made up a default account ID also. If I click authenticate, and it evaluates it in real time, no button, no presses needed. You can see that this one is pretty good in words. If I instead type password 123, it will just tell you it's weak, right? Already the system is telling you that it's pretty weak. So that means our previous things were working. Next, if I go to the batch, here you can just get the previously generated all the passwords. It's working sort of like a repository. So all of those that we generated of up to like 19 limit, the password limit and the length, you can again toggle with the uppercase, lowercase digits and symbols, generate a batch, and it will give you a batch of phrases and passwords. And you can actually export this to CSV. So now you can open this file, it's downloaded already, and you get a whole password batch along with its score and level of breakage capacity. And that's CRYPTEX, every module, every function, every concept. This was my Idea.3 submission for AICTE OASIS Infobyte Python developer again, and I'm proudly here to show each bit of it. So the code is clean, the architecture, the logic, every design decision ties back to real cybersecurity principles, and I thank you for watching.